Okay, good evening. This is week 2, Thursday. The agenda for today is we are going to do 2 more examples on centric buckling together with the one that we have not finished on last Tuesday. Then we are going to do something slightly different. Okay, we're going to look into eccentric buckling, okay, if time permits. Okay, so last Tuesday, we did this question, okay, and I have not finished it yet. Okay, so where we did up to is okay, before where we did up to, objective of this question is to determine the value P, and the value P, how much P can take, is dependent on the member, and the member is member which is this member which will fail by buckling, member BC. Then we investigate buckling, the possibility of buckling in 2 planes, YZ plane and XY plane. And then when we formulate everything, okay, we realize that the critical load for the XY plane, which we have calculated, was 178.887 times 10 to the power 3 pound force. Whereas in the XY plane, it is sitting at 79.51 times 10 to the power 3 pound force. And then we calculate the critical load that the structure BC can take due to buckling is 26.503, which is below 36 times 10 to the power 3 pound force. Okay, so this is where we last stopped. Pardon me, I need to adjust something on my screen. All right. So we still have not determined P. The objective is to determine P. So I'm going to sketch a multi-body. Okay, I'm going to start on a new page. I'm going to start with a multi-body. Free-body diagram. So I'm going to take this image. Okay. So this, we're going to sketch the free-body diagram. So we know that member BC, right? So this is our member BC. So this is C, this is B, and this is under compression, right? Then we have member BC connected to member AB. Okay, so this is point B, and this is point A, right? So I'll shift this slightly. And due to the fact that we have to obey Newton's third law on member AB, right? So B is in compression, so the reaction at B on member, so this is member AB, and over here this is member BC. Okay. So we know that over here BC, right, the force we calculated is 79.51 times 10 to the power 3 pound-foot of force. And we know that there's 2 components, and now I'm going to call this transformation based on our free body diagram. This is X, Y, and this is rotation Z. We know that over here, we will have, this is not very well, hold on. So we know that there's 79.51 times 10 to the power 3. This is the resultant. Okay. So we know that there is going to be a by, and we are aware that there's a bx over here. Now bx will not affect the value of p, okay, because bx is not going to induce any moment. It's only by that will induce a moment. Okay. So now what we are going to do is we are going to determine by. Okay, so first of all, we are going to determine by. Okay, this is because by were induced or generate, okay, will cause a bending moment about point A, because point A is pinned. Okay, bx will not generate, okay, a bending moment about point A. This is because bending moment in case some of you could remember, is equal to force multiplied by perpendicular distance. Okay, and bx has no perpendicular distance about point A. So that's why it's not considered, but by will. Okay, so there are a few ways to calculate. So there are a few ways to calculate by. Okay, so determine by. So by, one way of doing it, okay, is we know that the resultant is 79.51. So you can write 3 over 5. Why 3 over 5? Because the perpendicular height is 3. This distance is 5. Okay. So those two are the same orientation as the vectors for the forces. Okay. So this is equal to by divided by 79.51. So with this, we know that by is equal to 3 over 5 multiplied by 79.51. So this is equal to 79.51 power 3. So it's equal to 47.706 times 10 to the power 3 pound force. Okay, so this is one way. Method number 2, if you don't like this or this method of doing it, we can look for an alternate method, and the answer will be the same, will be slightly longer. So what we tend to do is we want to find this angle theta, right? So we know that tangent theta is equal to 3 over 4. Sorry, 3 over 5, right? And then from here, theta, so 3 over 5 inverse tangent in degrees is 30.8 degree. Okay. So from here we can also do the same calculation, and it is I think you guys can see where I'm going with this. So from here you have tangent 30.963 is equal to By over the resultant force, which is equal to 79.51 times 10 to the power 3. So from here, By, so tangent 30.963 times 9.51 power 3 is also equal to 47.705 times 10 to the power 3 pound force. Okay, so the answer is the same. You decide what you want to use. Okay, both answer will be the same, right? So we are where we have determined where are we now. We have determined By is equal to 47.706 times 10 to the power 3 pounds. So we're going to take moment about point A. Okay, so we're going to take moment about point A, and then from there we can find P. So what we are doing there is we are going to perform static analysis. So static analysis is anything there's any moment causing an anti-clockwise rotation will be positive. Dimension about moment about the z-axis at point A will be equal to 0. So that is why we call static, because nothing is in motion. So from here we have By is going to anti-clockwise 4 or 47.706 times 10 to the power 3 multiplied by the perpendicular distance of 4. Now down here, you don't need to change to inches because both distance we are going to use in feet. Okay, so you're fine, but you have to be, I'm not sure, then change everything to inches. Yeah, let me change everything to inches. Okay, and then minus by P multiplied by the perpendicular distance, which is 8 multiplied by 12. The whole thing is equal to 0. So from here, P will be equal to 47.706 times 10 to the power 3 multiplied by 4 multiplied by 12 divided by 8. So the allowable P will be equal to 23.853 times 10 to the power 3 pound force. Okay. So that is for this problem over here. Pretty straightforward. Okay. I'm going to do another example or another problem. So example number 1, because the other one was continue from last week. So this is a whole new problem. So you can get all these images from last week's notes, okay? It's the same thing. Oh, before I go on, any question regarding this example they've just done? Anyone, please? Okay, I don't see anyone have any problem. I'm going to carry on with this example number 1. So this example is if the diameter of the solid L2 steel rod is 50 millimeters. Okay. Determine the maximum mass at C that the rod can support without buckling, and we're going to use the factor of safety equal to 2. Why I want to do this problem is what is common over here is we have a situation over here. Okay, so what I want to highlight is, again, we have a rope. Okay, so this is a rope. So we on last week, if we look at last week's work, right, we did this example, right? Again, there's a rope, and I highlighted that the rope